show a simple example of a robot that doesn't really do much. But it's cute, and that's what really attracts people. Let me just start for a while. So my topic is about indirect communication in robotics, which actually I think is a continuation of what you were talking about, Andre. Is it on? It's even hard to start it up. Yeah, there you go. So I'll just let it ride around for a while. I'm not recording a bit, don't worry. So I'm Boris, and my email is there, my social media, Twitter, Instagram, Facebook, LinkedIn, all hand my surname. The year there is not my birth year. It's when I started researching on this topic and like just generally reading about it, and eventually it came into my research. So the topic is indirect communication in robotics. I think we all know what robotics is so already now, otherwise we wouldn't be here. Indirect communication is what I really will focus on. And so I'll tell you what the indirect communication is, and then I'll tell you why it's important to consider indirect communication, where it is important, where it's appropriate, and then how we actually use it. So indirect communication, my definition at least of it is the communication is not directed towards a particular recipient, and it's also non-structured. So this is the list of things that I consider to be indirect communication, which are actions, they're gestures, me for example telling Miro to stop. So if I don't want to come close to me, I'll just show my palm and it's supposed to go away or just turn off. The body language, the usual one, you're being close, you're afraid, you do this. The facial expressions is if you're disgusted, if you eat something, your face changes. The gaze, if you're obsessed. So it incorporates actions, gestures, body language, facial expression, gaze, but at the same time it's natural language. I think it's still indirect though, because it is not as structured as our natural language, the language that we speak, because on the language that we speak, there's so many rules, there's grammar, there's all that. Sign language is still evolving. So by the way, the list that I made, it is supposed to be ordered from more obvious indirect communication types to least obvious ones. And the text in bold is what I'm actually interested in my research. So I'm interested in looking at gestures and sign languages and making the robots available to people with disabilities. So since we're talking about robotics, how would you show robots using indirect communication? Which type of indirect communication would you use? You wouldn't use a dress to describe a robot, for example, or a gaze. I think the most appropriate one are gestures or actions, and in the media there are examples of that. So for example, one way I think everyone's familiar with how to show a robot is to do this, right? That's the robot that. And another one, you can show clocks spinning. So in fact, these two gestures are used in British Sign Language to describe the robot. So now an important question is why we need indirect communication. So first we'll consider humans. I think for humans it is just a habit. If we talk about something, we eventually emphasize on the things that we talk using gestures, let's say. And I don't really know why it became a habit, but I think we just want to convey an additional meaning when we talk about certain things by, again, emphasizing the certain aspects that we're talking about. And whether the additional meaning can complement what you're saying, or that they actually can work the other way around, it can let's say you're being sarcastic, so it actually damages the things you're saying and creates a different meaning. Other point that I want to make is that indirect communication is very useful for people who cannot use the direct communication or natural language to talk. So people with disabilities, they would require to use gestures, and it became so important that there's sign languages that are being developed in every country. So we see that for humans it is important, the indirect communication. The question is why it would be important for humans, or for robots. So since we're talking here again about robots being in the society and being integrated and being all around us, I think it is appropriate to say that a robot should resemble a human, although there are concerns that it should not really, because why would you create a robot that would look like a human or do exactly the same things as human? So there are pros and cons, and there are supporters on one side and the other side. But I think it's an interesting area to go into, to actually create robots that would be exactly like humans, just to see what actually happens, will we accept them or not. So another thing is the gestures. They're much more rich. They're much more complicated, and there's a complex information needed in gestures. So let's say, for example, the screen now goes black, and I have no idea what to do. And Hazel pointing somewhere, and I would be like, oh, probably I should go there to fix it. So you see, one simple gesture, pointing, would mean a lot. But obviously, there is context and all that is related to it. Another point is, right now, to tell the robot what to do, I have to literally connect to it. I have to use my laptop, I have to establish the connection, send the command, and wait for the response, and eventually the robot will do something. So that means there is something on the board of the robot that accepts those messages. Imagine what if the thing that is there malfunctions or it breaks, and it breaks at a very important moment when the robot is saving a human life, for example. Then we have to communicate with the robot in other ways rather than just sending the messages directly. So I hope we established that it is in fact important to have indirect communication between the robots and the humans. And I want to do a simple poll. I don't know how much time we have for the poll.
Yeah, okay.
All right. So I'll tell you what these robots are used for, and I want you to reply to me by just saying, who are for, who thinks that. Okay, so I'll tell you what every robot is used for, and you will tell me whether this robot needs indirect communication, whether it has to communicate back to the human in, say, gestures, and has to understand the gestures that the human is telling the robot. So, like, for example, we have the big dog, the first one on the left-hand side, which is used in the military, and it carries equipment for the military in the field. So who thinks that it needs to understand gestures or gaze or actions of people around it? Just raise your hand. Okay. What about the second is Aibo. It's developed by Sony in Japan, and it is used. It's supposed to be used as a pet in a household environment, to be more like your friend. So who thinks it's supposed to know what you're telling it when you're gesturing? Basically, it seems like more people. The third one is Pepper, and the intention behind it is to put it in the stores so it can assist people to direct them towards the certain places they want to find a certain good to buy. So who thinks it's supposed to know what people mean when they gesture certain things? Okay, quite a lot as well. And we have the last one, which is the cooker robot, which is used in manufacturing, and it usually sits in a cage, and it performs really precise movements, and it's pre-programmed. There is no, changing in its software as it operates. You just program it to do sort of one thing, and it does it for you. And it sits in a cage. It's not supposed to even see people around because it's really, really dangerous. So the thing is that it should understand human gestures. Raise your hands. Yeah, so I think we all understand that there are robots that are built for certain purposes that do not require complete understanding of a human being. But what I wanted to say with that is that when there is a person in the loop, when there is a person working with robots, trying to achieve a common goal, you must understand human intentions or humans, where the human is looking at, how it's behaving. So, how to actually understand the gestures, the indirect communication. The understand here is in quotes, as Andre was also pointing this out, is that we don't really try to understand, because understanding, we don't really even know what it means to understand. The Google tries to understand natural language for so many years, and I think it's failing. So instead of understanding what we actually do, we recognize it. We recognize the speech, we translate it into the text, and then we try to use it. We try to respond in appropriate ways. So those are, I think, the main blocks, really. So this is exactly what we do with the indirect communication as well. We don't understand it, we just recognize it and try to respond somehow. So how it is being done? Well, let's say I'm showing the robot, again, the palm, to say, I don't want to play with you, please go away. So what the robot does, this one guy there, it has two cameras in its eyes. So it is supposed to take the picture. And before, what was happening is that once it takes the picture and sees my palm, it reads every pixel in that picture and compares them all to each other. And it tries to use simple rules of like, if there is a if there's a pixel with this color in the middle, and there's surrounding pixels around it that are similar color, that means probably there's a palm. So that was used before. Nowadays, well, we discovered a more powerful approach, which is machine learning. And I think the problem that was with the machine learning in the very beginning is that we tried to use machine learning for everything. Just creating one algorithm, just put it on any problem that you can have, and expect a reasonable outcome from it. And we were getting okay results, but it was still not enough. So I think for the future, there's a question mark in there, because we don't really know what's going to happen, and we don't know where the research is going really, and what will be the next boom of methods or techniques that we're using for understanding. But there are indications. Right now, the machine learning, rather than being one solution for everything, we actually try to use it for certain problems and modify it and create the solutions that actually work for that one particular problem. And I think it will go more into that direction. So this video here, it shows, so there is a robot in, okay, I'll start. So there is a robot, cleaning robot, this guy here, like a Roomba. And the point is to program for the user, without actually writing the code, to program the robot to not clean the kitchen when there is a person on vacation, no matter what time of the day it is, or something like that. So you see in this what happens. The robot, it approaches the kitchen in order to clean it, and there's a human inside. The robot enters, human sees the robot, and it doesn't like the robot there, so it comes and kicks it. So it is a negative feedback for the robot, and so the next day or after a while, the same situation, the same scenario, the robot comes to the kitchen, the human is not there, and the robot slowly enters and starts cleaning. So after a while, because this learning type, it requires time. So this one example wouldn't be enough. So it would require a couple of time to do the same. The robot will learn that it should not go to the kitchen eventually when there's a person inside there. So So this is the testing. Again, the robot starts going to vacation, and you see the graph shows if the line goes up, that means the robot is most likely to come into vacation. So in the beginning, when there was no human inside, the robots thought it would go to vacation, and then the person enters vacation, the graph goes down, and the robot stops and waits. And the graph is quite low at the moment. And eventually the human does some sort of coffee preparation, whatever. And and it finishes, exits, and the graph changes, starts going up, and the robot decides to go into the kitchen. So it's, I think, quite useful when you don't want noise in the kitchen when you're having your breakfast or dust everywhere. So yeah, that's all I really wanted to say. Again, if you have any questions, find me using the email or the social media. And a small advertisement, there's a Timo. Timo is a monster that's going to be at the Science Festival from tomorrow until Tuesday, where we'll show you how to bring the Timo to real life using science, art, technology,